Today we're going to be learning about what percentage actually means, and we're going to be looking at converting percentages to fractions and decimals and going the other way, converting fractions and decimals to percentages. Now the word percent is actually trying to tell us what it is about. The part of the word here, cent, is referring to 100. You might remember century meaning 100 years, or centimetre, that actually means 100th of a metre, but it has to do with being 100. I sometimes like to imagine the percentage sign is actually trying to tell me. If I take the line bit and then I put the two circly bits afterwards, I sort of imagine that it's trying to tell me that it's out of 100 there. So there's only really a couple of things you need to remember here. If you've got a percentage and you want to go to a fraction or a decimal, so that's this direction, you're going to divide by 100, because remember, percentage means something out of 100. So it makes sense, if we've got a number and we divide it by 100, we're going to get a percentage. Now, that also means if we go the opposite direction, if we've got a fraction or a decimal and we want to go to a percentage, we're going to do the opposite. We're going to multiply by 100. Now you might think, oh, okay, well, I'm doing the same thing for a fraction or decimal. So if I'm going from a percentage to a fraction or a decimal, I'm divided by 100. Okay, but they're two different things. We're going to be thinking about dividing by 100 fraction style or decimal style. So I'll show you what that means. Let's focus on percentages to fractions first. So we said again, going from a percentage to a fraction or a decimal, we're going to divide by 100. And I said we're going to do that fraction style. That means when we divide by 100, if we had 20% here, we're going to do 20, and instead of writing a division sign, we're going to write it over 100, because we said that fractions are just divisions in disguise. So 20 divided by 100, well, that division sign is a fraction in disguise. 20 goes here, 100 goes here. So that's what we're going to mean by doing it fraction style. Dividing by 100, we're going to make it look like a fraction. So we've got a vinculum, and we've got over 100 here. Now, whenever we have a fraction, we always need to check that it's in the simplest form. So I notice that 10 goes into both of these numbers, so I could divide 20 by 10 and 100 by 10. I get 2 tenths. Now, I didn't identify the highest common factor there, but I notice I've got 2 over 10, and both of them being even numbers, 2 goes into 2 once, and it goes into 10 5 times. So our simplified fraction is 1/5. We always want to remember to simplify fractions. So let's actually apply that to some of these questions here. I'm going to demonstrate A, E, I, and maybe J. Actually, no, I'm going to do H. So I'm going to have a go at these ones, and I'll leave the other ones until after I've gone through these examples for you to stop and have a go yourselves. Okay, so 40%. We said that we've got to divide by 100 fraction style. So that means we're going to have 40 over 100. Now you might notice that 10 goes into both of these, or you might actually notice that 20 goes into both of these numbers. 20 goes into 40 twice. 20 goes into 100 5 times. So that means we're going to be left with 2/5. And if we relate that to our previous question, 20% being 1/5, it makes sense that 40% is double that, 2/5. So that seems a reasonable answer to me. Okay, the next one we're going to have a look at, 25%. Now you might recall that this is a quarter. But the reason it's a quarter, if we have 25 divided by 100, because remember, going from a percentage to a fraction, we divide by 100. And the highest common factor that we've got here is actually 25. 25 goes into 25 once, and it goes into 100 4 times. So that's why 25% represents a quarter here. Okay, this last one, actually no, let's do H next, and then we'll have a look at I. So 150%, we've got larger than 100%. So let's look at what actually happens when we do that. So 150%, still going to do the exact same thing. We're going to do 150 divided by 100. Now let's simplify this down. I see 10 goes into both, so I could cancel off a 0. And looking at what we have left, I reckon we can have a 5 goes into the 10 twice. 5 goes into 15 3 times. So we could write that as 3 over 2. We have converted that successfully to a fraction. Now that's an improper fraction. I think they're pretty great, but if the question asks us for it as a mixed number or a mixed numeral, we need to think, well, 2 goes into 3 once, and there'd be 1 remainder over 2. So remember, improper fractions I think are pretty great, but mixed numerals, you also need to be able to do that. But I would be perfectly happy with you leaving that as 3 over 2 as an answer. Okay, this last one that I'm going to go through, and then I want you to attempt the other ones yourself. We've got 1 1/4% though. Now you might think this is already a decimal, sorry. You might think this is already a fraction, not a decimal, but it's got a percentage sign there. So we need to do exactly what we would normally do. We need to divide it by 100. Now the problem is, when we deal with mixed numerals, things get a little bit messy. So we actually want to change this to an improper fraction first. That's why I like them so much. So remember, if we've got 1 1/4, we're going to do 4 times 1, because we have 1 whole, and we need to think how many times would that work as a quarter. So that would be 4 quarters, and we add on the 1. So that's going to be 5 over 4. Still have that percentage sign though. It's still a percentage. It's a strange looking one, but it's still a percentage. Now, we want to do 5 over 4, and we want to divide that by 100. Ooh, that's looking a little bit yucky though. So what if instead, because we've got a bit of double-decker fraction action, let's maybe write it like this for a moment to observe. So 5 over 4 divided by 100. Now recall, we practiced doing some divisions in earlier lessons. If I had 5 over 4 divided by 100, I could actually do a little bit of reciprocal action here. So remember, when we had a fraction divided by a number, we write the first fraction as we normally do. We change the division sign to a multiplied sign, and we take the reciprocal. Now, how do we take the reciprocal of a whole number? Whole numbers can be written over 1, so I could flip that upside down to have times 1 over 100. So dividing by 100 is the same as multiplying by 100th. That makes sense. Now we see if we can cancel anything. Nothing to cancel this way, can cancel things in this direction. 5 goes into 5 once, goes into 120 times. Can't cancel anything this way, can't cancel anything this way. So we're left with 1 over 4, I'm just going to rewrite it so you can see it, times 1 over 20. So that gives us 1 over 80, because we do 1 times 1 for the numerator, 4 times 20 for the denominator, and we can't cancel off anything else there. Okay, I'd like you to pause, take a moment, have a go at questions B, C, D, F, G, and J, and I'll put the answers up in a moment. Okay, I hope you took the opportunity to pause. If you didn't, last chance. Okay, let's do it. Okay, so the answers for B through to, oh, nearly forgot this one. That would be 3 over 10. The answers for the first ones that I asked you to do by yourself are up there. You'll notice for part D, we couldn't actually simplify that down anymore. Oops, you might have noticed I made a mistake here. For 60 over 100, I wrote 0.6, didn't read the question properly. It's asking it as a fraction, not as a decimal. So 60 over 100 would be the same as 6 over 10, so we could write that as 3 over 5. Okay, I've answered all of my questions as fractions. I left J because I thought you might appreciate having a look at going through that one together. Okay, remember, it's always fine to do an algorithm on the side of your page. So we want to change this one. We've got a fractional percentage, still a percentage though, because we have a percentage sign attached. I want to make that into an improper fraction. So you need to do 6 times 37 first. So 6 times 7 is 42, so we pop the 2 and then the 4. 3 times 6 is 18, add that, 22. Now we need to add that 5, so that means this would be 227, 222 plus that 5 over 6. Still a percentage, haven't changed anything here, still a percent. So we could divide this by 100, or we could do the trick that we did before. We could write that division a bit like this. And we know we could rewrite that as 227 over 6 times 1 over 100. Because we know that dividing by 100 is the same as multiplying by 100th. Okay, so Can we cancel anything in this direction? No, I don't think so. And anything in this direction? Perhaps not. Is 227 divisible by 3? 2 plus 2 would be 4, plus 7 is 11. Not divisible by 3 or by 9. So let's just multiply across the top and the bottom. So we get 227 over 600. And no, can't think of any common factors there. So I think we're all good. Let's have a look at the next examples. Okay, so going from a percentage to a decimal, we're going to divide by 100 again, but let's do it decimal style now. So recall, dividing by 100 moves the decimal place 2 places to the left. So for 35%, whole number has a decimal point here, and we're going to move it 1, 2 places to the left. We have to put the point there, and then a 0 beforehand, so it becomes 0.35. So this is pretty quick. Let's see if we can do all these together. This would be 0.40. Oops, it's not a percentage anymore because we have divided by 100. And we did it decimal style. So our answer is a decimal. If you're the kind of person like me who might miss that in a test, you might want to highlight this. Okay, let's keep jumping these decimal places. So 0.85. Jump, jump. 0.6, that's what I tried to give that answer to last time. Jump, jump. 0.13. Ooh, we've got one with a 0.5. We can handle that. Equals 0.325. Now this one, still a percentage, so we still need to divide by 100. So we need to jump 1, 2, just like normal. Put our decimal point there. In this gap, we need to put a 0. And remember beforehand, we always want a 0 in the units place if there's nothing. So that actually becomes 0.002%. If you get confused with something like this, sometimes it's handy to cover up the number and think, what would I normally do? What if that number was 10? I'd divide by 100. Okay, so in this case, it's 0.2%. Still going to divide by 100. Don't let those tricky numbers confuse you. Okay, jump, jump, 0.25. Now we've got the decimal point here. Jump, jump, 1.10. Jump, jump. Ooh, this one's going to be a very small decimal. 0 point, we need a 0 here, 0.0 here. So we're going to have 0.00045. That's a small one. And 1%, jump, jump, 0.01. Now, you could also check by converting the other direction, and we'll talk about how to do that soon. But make sure, if you see a percentage sign there, you still need to do the same thing you do for a whole number as if you do for a little decimal like this one, or like this one here. Still the same process, we're just trying to trick you. Okay, go the other way. We're going to be multiplying by 100. So it doesn't matter if we're going from a fraction to a percentage or a decimal to a percentage, we're multiplying by 100 each time. So you see in the first example, we've been given 1/5. 1/5 times 100. Sometimes it's nice to write the percentage sign here to remind ourselves that our final answer will be a percentage. I like to put my percentage sign in the final step, but you do what works for you. And this has been written over 1 because when we've got a fraction times a number, it's nice to have a fraction times a fraction. So let's actually have a go at doing some of these. So let's do times 100 over 1 for this first one. I like to cancel anything down if I can. Nothing in this direction, but I can do 2 goes into 2 once and into 150 times. So that leaves us with 1 times 50 on the numerator, and then 1 times 1 on the denominator, which we know we could just write as 50. Now we're answering as a percentage now. So we need to pop a percentage sign at the end. So remember, a whole number divided by 1 is just itself. Let's see if we get that in future. So times 100 over 1. 50 goes into 50 once, and it goes into 100 twice. So we're going to have 22 on the numerator. We'll have 1 times 1 on the denominator. So we know 22 divided by 1 is just going to be 22. 22%. Okay, let's have a go at, I did A then C, let's do B now. So times 100 over 1, this one's quite nice. Cancel 1, cancel 1. 100 goes into 100 once. And remember, when we cancel everything off from the numerator or the denominator, we have a 1 that remains there. So on the numerator, 14 times 1, we'll have 14. And on the bottom, 1 times 1 is just going to be 1. So 14 divided by 1, just 14. So 14%. Biggest thing with these is to remember the percentage sign at the end. Okay, I'd like you to have a go at the ones that we've got remaining, and I'll put the answers up in just a moment. Okay, they weren't too bad for me. I just wanted to point out a couple that you might have found a bit tricky. Okay, let's look at E and G specifically here. So with E, we didn't have anything to cancel off in this fraction here, and that's okay. So we're just going to multiply the numerator and the denominator, so we get 100 over 3%. That's an improper fractional percentage, and that's okay. Sometimes it's easier to visualize things as a mixed number though. So 3 goes into 100 33 times with 1 remainder, so we pop that over the 3. So 33 and 1/3%. You might also recognize that 1/3 represents 0.3 recurring. So you could also write that as 33.3 recurring percent. All 3 of these options would be fine if not specified on a test. With this G here, when we cancelled things off, we got 150 over 2. You might have also cancelled in this direction. So you might have cancelled off perhaps the 2 and the 30. So 2 goes into 2 once and it goes into 30 15 times. So you might have ended up with 75 over 1. Doesn't matter how you get there, you would have still gotten the same answer of 75%. Oh, I didn't have a go at these last two. Let's maybe do them together. Oh, I remember what I wanted to mention. J. We got a value larger than 100%, and that makes sense because we've got an improper fraction. We've got a number, a larger number divided by a smaller number. So we're going to have something larger than 100% because this fraction is equal to something larger than 1. When we multiply something larger than 1 by 100, we're going to get something bigger than 100. Okay, let's get back to what we were doing. So let's see if we can cancel. We can say 4 goes into 4 once, goes into 125 times. Then we've got 5 lots of 25. So if you wanted to on the side of your page, you could do an algorithm, or you could go, 4 lots of 25 is 100, another lot 125. And we need to not forget that percentage sign at the end. Have I remembered my percentage signs for all the other questions? Yes. Okay, this last one, we previously said that could be written as 227 over 6. And to get it into a percentage, we need to multiply by 100 over 1. Cancelling off anything we can. I think that 2 goes into both of these numbers. So 3 and 50. Ooh, we said 227 before was not divisible by 3. So we need to do a bit of a yucky one. 227 times 50. Do that on the side of our page. So I can just pop that 0 down here and just do this multiplication. 5 times 7 is 35. 2 times 5, 10. We've got 13. And 2 times 5 is 10. 11350 over 3%. Oh, that was a doozy. So even though these last two were a little trickier, we just needed to remember, change it to an improper fraction first, multiply by 100 like normal. We've practiced doing algorithms for numbers, so you might need to use those sometimes for some bigger numbers, and that's perfectly fine. Now, although for this topic you can't use a calculator in the test, it is worthwhile mentioning how you actually write fractions, or I should say mixed numbers, into the calculator, so I'll mention that really briefly. If you want to input a fraction, you might be used to using the fraction template here, but the problem is, so if I did 6, and I did that because I wanted to put a fraction next to it, doesn't work. So what I want to do instead is I want to use the shift button, and then I want to click this here. That means we're going to use this template above, and that's the mixed number template. So I could write 37 and 5/6. I'll actually do the question here. We multiplied that by 100, so let's just double check our answer, but also practice doing this in the calculator. Now your calculator might present that as a fraction or a decimal first. And remember, the way to swap between them is this S to D button. So that's that as a decimal. Let's check if we got our fraction right. 11350 over 3. Great, and that's a percentage, so we had our percentage sign there. Okay, last little bit, we're going to do it decimal style now. Multiplying by 100 moves the decimal place 2 places to the right. So these can be quite quick to do. So 0.5, boom, boom, pop the 0 there, point goes there. We could write 50.0, but we don't have to. We know all whole numbers have an invisible decimal point afterwards. So 50, and don't forget your percentage sign. Okay, pop, pop, 40%. Pop, pop, 25%. These are pretty quick to do. So multiply by 100, that would be 35%. Be careful with your decimals, 1, 2. This one would just be 3%. And that makes sense because it's 300ths. 300ths, remember percent means over 100. Pop, pop, 11%. Okay, let's look at this one. Moving it 2 decimal places means we're going to get 56.7% here. And this one will be 12.3%. 2 jumps, we get 70% for this one. And this one we've got a number, a decimal I should say, that's 1 or greater. So jump, jump, makes sense, we get 120% for this one. Ooh, now this one. Still need to do the same thing. So we need to go jump, jump, and this is going to be 2,000%. And this one here, jump, jump, oh my goodness, 3,123%. So all of these were decimals that we were given. We were asked to change them to a percentage. Okay, that's the end of our lesson. Let's check if we have covered the things that we wanted to learn at the start of today's lesson. We now should understand the percentage is a number out of 100. We know percent means per 100. To convert from percentages to decimals and fractions, we know that we need to divide by 100. So we've learnt that. And to be able to convert fractions and decimals to percentages, we know we multiply by 100. Remember, when we're dividing or multiplying by 100, we're thinking, are we doing this fraction style or are we doing this decimal style? Now's the opportunity to practice this. Let me know if you have any questions.